1 equals, and divided by 1, go ahead, you don't need to type divided by 1 in the calculator, it's going to give you the exact same thing. I end up with 97.9 grams of magnesium chloride. Great. Well, what does that mean? All right. What we are saying here is we are starting with 25 grams of magnesium. Let's get something different out here. Okay, we're starting with 25 grams of magnesium. After this reacts, 1 mole of magnesium reacts with 2 moles of hydrochloric acid. It's going to produce 1 mole of magnesium chloride and 1 mole of hydrogen. Well, we have 25 grams of this. All right. When this magnesium reacts with our hydrochloric acid, it's going to produce 97.9 grams of magnesium chloride. We're just seeing how much magnesium chloride we can produce with 25 grams of magnesium. All right, limiting and excess reactants. Okay, let's take a look first and foremost at our word equation here. So if we react 75 grams of sodium with 75 grams of chlorine, how much sodium chloride can we produce? So someone's doing an experiment and says, well, I got 75 grams of chlorine and, well, I may as well just use 75 grams of sodium. When we're talking about limiting reactants, limiting reactant means either sodium or chlorine, right? The reactants in our equation. Which one's going to run out first? Right? We have 75 grams of both. How are we going to find that out? Okay, you need to see which one is going to run out first. Well, we can do that with math. The excess reactant is obviously either sodium or chlorine. The excess reactant is not the limiting reactant. It means we're going to have some leftover. All right? Right here we're making table salt. So if sodium is the limiting reactant, then chlorine is going to be the excess reactant. And we need to know, well, how much chlorine are we going to have left? Okay? So if we look, number 1 right here in the red, we're going to write and balance the equation. 2, we're going to find the limiting reactant. 3rd, we're going to use the limiting reactant to find the mass of sodium chloride. We're going to see how much table salt we can produce. And as a bonus, which you will be accountable for on your quiz, you're going to calculate the amount of excess reactant which will be left over once this reaction is complete. Why is that useful? Well, chlorine in this equation, let's say we're going to react solid sodium with chlorine gas. Okay, chlorine gas is not a good thing to just have floating around. Pretty poisonous. It has been used in wars, okay, to, well, try and kill people. We don't want that floating around. If we have excess chlorine, we need to figure out what in the heck to do with it. All right, so go ahead, pause the video. Why don't you go ahead and write this reaction? All right, try and balance it, and then let's work on the math in the next step. So you can see right here, I have 2 moles of sodium. They react with chlorine to produce 2 moles of sodium chloride. All right, so there's our balanced reaction. Pretty simple, pretty quick, pretty easy. All right, now, remember from the word equation, we have 75 grams of sodium and 75 grams of chlorine. Which one is our limiting reactant? Well, remember the steps from the last slide down in the bottom left-hand corner. All right, really recommend understanding those, all right, committing those to memory. Here's why. Step 1, like everything else we have done, is write and balance the equation. Step 2, we need to convert our masses to moles. So if I gave you 2 moles of sodium and 1 mole of chlorine, then step 2 is already done. Here, we have to complete step 2. Okay, so as we look, and let's start with sodium. We're going to convert this to moles. All right, we have 75 grams of sodium. Sodium's molar mass is 23 grams. We're just going to make it easy. 23 grams in 1 mole. So we do that division, we divide it out, and we end up getting 3.26 moles of sodium. All right, same thing for chlorine. We start with 75 grams. We have to go ahead and Cl2, 70 grams is 1 mole, right? Because 35, but we have Cl2, 2 chlorines bound together. And that is going to give us 1.07 moles of sodium. Oh, excuse me, chlorine. Now, you are not done with finding the limiting reactant. Your next step here, all right, we are going to use the coefficients of each. So I can see I have 2 moles of sodium. All right, well, I see that 75 grams is equal to 3.26 moles, but I have 2 moles in this equation. So I'm going to divide sodium by its coefficient and find out that 75 grams, okay, is going to give me 1.67 moles of sodium. Now chlorine, its coefficient is 1. Okay, so I have 1 mole of chlorine in this equation. We know that 75 grams is 1.07 approximately moles of chlorine. All right, so I do that simple division. Now, right here, this will tell you your limiting reactant. We've converted from grams to moles. Then we have divided by the number of moles of each individual molecule or mole or compound, in this equation. And we found that we can either make 1.67 moles of sodium or 1.07 moles of chlorine. All you're looking for is which one of these numbers are smaller. And that ends up being 1.07 moles of chlorine. So this right here is your limiting reactant. Okay, now we need to find how much product we can make. And obviously we have one product, so we're going to try and see how much 75 grams of chlorine is going to, how much 75 grams of chlorine can produce how many grams of sodium chloride. Okay, so we take a look and we see that we have 75 grams and we want to know how many grams of sodium chloride we can make. Now, let's go ahead, do the big train track method for this conversion. We've already done this conversion right here. 75, well, 70 grams is our molar mass. Moles of Cl2. We've canceled out our grams. Now we're going to use our molar ratio. All right, so I know that I have 1 mole of Cl2 to every 2 moles of sodium chloride. Right, and I just got those. This number right there. Right, this 1 from right there. And we're using those coefficients again, the molar ratio. And last but not least, we're already in moles of sodium chloride, so we're in moles of our product. We want to convert moles of our product to grams of our product. 1 mole of sodium chloride is, oh, that's Cl2. is 58 grams. I'm starting to pull in a random 2. I need to remember my ionic bonding rules. Okay, and this math is going to end up giving us approximately 124 grams of NaCl. Okay, so what we're saying is chlorine is our limiting reactant. Okay, and due to the amount of limiting amounts of chlorine, okay, so this 75 grams that we started with of chlorine will let us produce 124 grams of table salt. That 124 grams is known as your theoretical yield. Right? We're going to use that for our percent yield here coming up shortly. But finding your theoretical yield can be done by finding your limiting reactant, determining how much product we can use, and that's our theoretical yield. Lastly, I told you it's the bonus. We're going to find how much excess reactant is going to be left over at the end of this reaction. So what are we going to do? All right, so we know that sodium is our excess reactant. Okay, we know we have 75 grams of sodium chloride. We know we have 75 grams of chlorine. How are we going to determine excess reactant? We are going to convert 75 grams of chlorine, our limiting reactant, okay, grams of limiting reactant, we're going to convert that to grams of excess reactant, and we're going to subtract grams of excess reactant from grams of limiting reactant. Alright, so here's what we do. We know we have, once again, 75 grams Cl2. Okay, we need to convert that to moles. So math is going to look very similar. 1 mole Cl2. Alright, we've now converted to moles of chlorine. Now we need to use our molar ratio to convert to sodium. Okay, so use your coefficients. We have 1 mole of chlorine to 2 moles of sodium. And now let's find the mass of sodium. So we have 1 mole of sodium is 23 grams. Alright, from there we find out that gives us 49 grams of sodium. Okay, you're going to take this number, 49. Alright, remember this is from our limiting reactant. This is converting 75 grams of chlorine. If I magically converted that into sodium, alright, it would create 49 grams of sodium. And I'm going to subtract my 75 grams of sodium, which I got from what I'm starting with in the equation. So my excess reactant minus my converted limiting reactant mass. And I am going to get 26 grams. So that 26 grams tells me that once all of my chlorine is used up, I am still going to have 26 grams of sodium left over. So if I need to make more table salt, I've got 26 grams of sodium to do so with. Last but not least, let's take a look at percent yield. Alright, and using your theoretical yield from the previous equation. Alright, so what we just found out is that we have a theoretical yield. Alright, a theoretical yield of 1/24